So hello guys, for this video we're gonna find um we're gonna have three topics here. So we have length of curve, surface area, and centroid. So first we have length of curve. So example, so here we have a function. So this curve will be our f of x. And so how do we find the length of the curve? If this our limit a, and this our limit b. So we have here our formula. So this equals to limits of a to b, integral limits of a to b, square root of 1 plus dy over dx squared with respect to x. This formula is for finding a to b for dx. Okay, so how about if we find our c to d? Example, this one, like this one. For curve is over here like this. So what formula are we using? So we use this formula, integral of c to d, square root of 1 plus dx over dy squared times dy. This is the formula that we'll be using for finding our length of the curve c with limits of c to d. So when we're using this, this one will be I will equate it into x equals to f of y. Okay, when we're using this formula. So this formula, both of these are derived from the second line. So we'll have our few or one or two example for the length of curve. Okay, so let's give the example for a problem. So here we have find the length of the line segment given by the equation y equals to x3 plus x plus 3 from x-axis x equals to 1 to x equals to 7. So as you can see, we also can use this formula for the line. So let's draw our function. So this will be our limits from 1 to 7. So here, as you can see, we're finding it by x-axis. So the formula that we'll be using is this one, integral of a to b, 1 plus dy dx squared by dx. So in here, we can substitute our y is equals to x 6x plus 3, and our dy dx, which is 6, and then it's squared. So this will be dy dx squared equals to 36. So as you can see, we can now substitute our variables to the formula. So this integral of our a to b is 1 to 7. So this will be limits of 1 to 7 square root of 1 plus 36 dx. And now we can evaluate this. So so when we integrate this, so this will become square root of 37. So the integration of square root of 37 dx will be equals to square root of 37 x with the limits of 1 to 7. So our 1 to 7 is from here, our limits. Okay, and the integration of this 1 plus 36 was to 37. Square root of 37 dx will be 37x. So when we evaluate this very high value, this will become square root of 37, 7 minus 1. And this will become 6 square root of 37. This will be our answer. And this is the value of our line here, which is equals to 6 square root of 37. So next we have our next problem here. Find the length of the curve y is equal to x raised to 3.5 from interval of y equals to 0 to y equals to 5. So we can draw our function here like this. So our curve will be like this. So this will be our y is equals to x raised to 3 half, and as you can see, our interval is in y-axis. So this one c is equals to 0 here, this one, and here will be rd equals to 5 from this one. So as you can see, our interval is from the y-axis. So in the last previous equation, we used y is equals to f of x equation, but in this problem, we're finding out for the interval of y-axis. So what we're using is x is equals to f of y. So this one is what we'll be using to find the length of the curve. So now, how can we equate this y equals to x to 3 half? So we can do this. Y is equals to x raised to 3 half. We can square this by 2/3. So this will become y is equals to 2/3 equals to x. So our x is equals to y 2/3. And the formula we can use here will be integral of c to d square root of 1 plus dx dy squared with respect to y multiplied by dy. So here our dx over dy will be 2/3 y raised to 2/3 minus 3 over 3. Next, we can proceed with dx over dy is equals to 2/3 y, and 2/3 minus 3 over 3 is negative 1/3. So this will be squared. So our dx over dy squared will be 2/3 multiplied by 2/3. This will be 4/9. Y raised to 2/3. Okay. So now that we have our dx dy, this will be, now we can substitute on our formula here. So integral of c to d, or c to d, it will be valued as 0. Limits of 0 to 5. Square root of 1 plus our dx dy will be 4/9. 4/9. Y negative raised to negative 2/3 with respect to dy to y. So now we can solve this. Limits of 0 to 5. Square root of 4/9. Then separate this 4/9, y negative 2/3 to 9/4, y 2/3 plus 1 with respect to y. So now, to get the square root of them, we can separate it. So this will be integral of 0 to 5 square root of 4/9 y raised to 2/3, and then square root of 9/4 raised to y raised to 2/3 plus 1 dy. So by this, by separating them, we can get the square root of this one and this one. So this will be integral of limits of 0 to 5. This will become the square root of this is 2/3 y raised to -1/3 multiply by the square root of this one, which is 9/4 y 2/3 plus 1 dy. So we can solve this by using u substitution. So we can let this u is equals to 9/4 y raised to 2/3 plus 1. So the du of this one, multiplying, this become 9/4 2/3 y raised to 2/3 minus 3/3 dy. So here we can cancel this out. 9 to 3, 4 to 2. So this will become 2/3 du equals to 3 half y raised to -1/3 dy. And then this will become 2/3 du equals to y -1/3 dy. So in here, as you can see, this one is the same as this one and this one. Okay, so we can put our constant out. We have 2/3 on the outside, and this will become 2/3 du. This one, 2/3 du is equals to this one, our y here, and our dy. So also, as you can see, this one, the square root is equal to u. So this will become square root of u. So now here, we can't use our limit anymore because we already used the u substitution let u. So how do we solve this? We can put this as a is equals to 0. We can use the limit 0 equals to 9/4. Y will be 0 raised to 2/3 plus 1. So our a here will be 0 multiplied by 9/4 raised to 2/3 is 0 plus 1, so this will be 1. So for our b, we'll be using 5. Okay, so this will be 9/4 and 5 raised to 2/3. And we can use our calculator here to solve for this one. So this will become, our b will become 7.5790. Okay, and then we can now substitute our limits, which is the new value of our a and b. So this will become 4/9. From here, when you multiply this, we'll get 4/9 integral of 1 to 7.5790, which is the new value of our a and b. U raised to 1/2 du. So now this will become 4/9, and we can solve this. This u 1/2 will become u raised to 3 over 1/2 plus 1, which is 3/2 over 3/2. Okay, with the limits of 1 to 7.5790. Don't forget that. Okay, So now we can evaluate this. So by substituting our value here, our limit, so this will become 4 times 2 will become 8, 9 times 3 will become 27, and then our u will become 7.579. Let's put 3 half here, minus our lower limit will be 1 raised to 3 half. So by using calculator, the answer for this will be just 5.8859, and this will be our answer for the length of our curve here. So this will just become the value of this is just 5.8859. So that's it for our length of curve. So hello guys, for this video we're gonna discuss about how to solve the surface area of revolution by integration. In this we can solve by its y-axis or x-axis. So for the surface area, our formula for surface area will be surface area is equals to 2 pi integral of a, limits of a to b, our radius of x, multiplied by the square root of 1 plus f prime of x squared dx. So let's have our example here. We have y is equals to x raised to 3. Let's have our limits of 0 to 2, 0 to 2, and will be rotated to the x-axis. So now we can graph our function. So this will become our curve will be like this, and then with limits of 0 to 2, this one, and then our radius can be found here in the middle, or r, and then this for this problem it will be rotated on x-axis. So this will be related by this side, because in this side will be our y and this side will be our x. Okay, so our radius x is equals to y, and so our x equals to x cubed here. Okay, and then our f of x equals to x cubed. F prime of x will be just 3. The prime of x is just 3 x squared. So what we're gonna do is we're gonna square this both side. So the square of 3x raised to 2 is just 9x raised to 4. So now we can substitute this to our formula here. So this will become s is equals to 2 pi integral of limits of 0 to 2 x3 for our x value, this one. Okay, and this one will be the value of our f prime of x. So our f prime of x squared is just 9 x raised to 4. So 1 plus 9x4 dx. So from this equation, what some function or identities or formula we can use to solve this? So in this, I think we can use substitution. So we'll let u be 1 plus 9 x raised to 4, and the du of this will be just 36 x cubed dx. And then the du, we can just find our dx by du 36x cubed. Du over 36 equals to dx. And then we can substitute this now. This will become s equals to 2 pi integral of 0 to 2 x3 u raised to 1 half du 36 x3. And then we can use our limits here. So ru is equals to 1 plus 9. 1 plus 9x, or x will be 0. Wait, our x will be now, we'll be using the higher limit will be 2 raised to 4. So this will be just 1 plus 9 multiplied by 16. 1 plus 9 times 16, 90. 144. So this will just become 145. So now we can substitute this one. And as you can see from this problem, we can cancel out some of them. 2 pi over 36, the limit of 1 to 145. So here we have u is to 1/2. We can find this 36 here by canceling this out, cancel this out, and cancel this out. So now we have 2 pi over 36 with the limits of 1 to 145. U raised to 1/2 du. So now we can solve this further. So now let's find the antiderivative of u raised to 1/2. So u 1/2 plus 1 is just 3/2. So this will just become 2/3 u 3 squared. So here we also have 2 pi over 36. So 2 pi over 36 is just pi over 18 with the limits of 1 to 145. Now we can solve this one. So in this one we can cancel some of this. So 18, we can just put it 9 times 2. So we can cancel out 2 here and 2 here, and we can multiply our 9 here by 3. So this will just become pi over 27 u raised to 3/2 with the limits of 1 to 145. Okay. So now we can solve this. So pi over 27. You can use your calculator here in this part. So 145 3 over 2 minus 1 3 over 2. Okay, so as you can see, we can also try to use this one. 145 3 over 2, which is equals to 145 1 times 145 to 1/2. And as you can see, the antiderivative of 1/2 will just become pi over 27 145 square root of 145 minus 1. Or simply, this is just equals to, when you use your calculator here, just simply 203.044. So this will be your answer. So for our last topic will be centroid. So here we have our function. Find the centroid. So what are we gonna find here? It's the area of this part, the centroid of this. So for the area, this is equals to, finding this area first, this is equal to integral of limits of 0 to 1 minus x squared dx. So this is the formula for the area. So here we can plug in our variables. X minus 1/3 x3 with limits of 0 to 1. Okay, by using the power formula, we can you can find this 1 3, and then we can plug in our intervals or limits. So x will just be 1 minus 1/3 1 cube minus 0 minus 1/3 0 raised to 3, or this will just become a 0 value. So in here you just find this 1 minus 1/3 is just 2/3. So this will be our area. But as you can see, we're finding out the centroid. So when finding the centroid, don't forget your area here. Okay, so x coordinate. So what is our x coordinate? Is this area. I'm gonna find the x coordinate of 0. This is equals to 1 over our area, which is this one. The integral of limits of 0 to 1 from here. Okay, x minus 1, or y here, 1 minus x squared dx. So basically this is just a formula for our x coordinate. So as you can see here, we have the problem, but we cannot still integrate this because we still have to distribute our x to 1, x to x squared. So we're gonna put this on 1 over a, or a, which is value of 2/3, with the integral of limits of 0 to 1. So x times 1 is just x minus x times x squared is just x cubed dx. So now this one, we can integrate this. Okay, so here we can integrate now this one. So 1 over 2/3 is just reciprocal of this, it's just 3 over 2. X, by using the power formula, we can integrate this as 1/2 x squared minus the entire dx of x3 is just 1/4 x4, and then we can just plug in our limits here. So this will become 3 over 2 1/2 and 1 squared minus 1/4 times 1 raised to 4, and this will become just 0 minus 0, because 0 to the x is just 0. So now we can find the answer. So as you can see, this one is just 1/2 minus 1/4. So 1/2 minus 1/4 is just 1/4. Okay, so we have 3/2 here, and this one will be 1/4. So by multiplying this, we just get our x coordinate as 3 over 8. So next, moving to our y coordinate. Still have to find our y coordinate here. So our y coordinate is just 1 over area with the limits integral of 0 to 1, 1/2, and our y here, which is 1 minus x squared. And don't forget to square this in your dx. So this is how our y coordinate is set up. So we can repeat what we did here in here. So now we can just put this up. So 1 over 2/3, and we can as you can see, we still have 1/2 here, our constant. We can just take it out. 1/2 integral of 0 gives us to 1. And then as you can see, we still have to integrate this one. So 1 minus x squared raised to 2 squared, just x 2 times 1 is just 2. 1 squared is just 1, minus our 2 here will be 2x 2 plus our x squared 2 squared is just 4, so x4 dx. Okay, so now we can integrate this. So this will just become 3 over 2 times 1/2, and we can integrate this. 1 dx is just x minus antiderivative of 2x2 is just 2/3 x raised to 3 by using power formula. It's the same as this, just plus 1 plus 1, so this is x raised to 5, 1/5. And we're gonna plug in again, same, so this is 0 to 1. So now we can use the plugin. So 3 half minus times 1/2 is just 3/4. And then we can use our plug into x, 1 minus 2/3, 1 raised to 3 plus 1/5, 1 raised to 5 times just 0 minus 0. Okay, and then we can solve this further. So we have here 3/4. We have the same denominator here, so we can just multiply this by 5 and by 3. So we'll just have here 15. 5 times 3 is just 15/15 minus 5 times 2 here is just 10/15 plus 5 times 3 here is just 3, and 3 times 1 is just 3, and 5 times 3 is just 15. Okay, and then we can just solve this. So 15 minus 10 is just 5 plus 3 is 8 with the same denominator, 15. So this will just become 3/4 multiplied by 15 minus 10 is 5 plus 3 is just 8 with denominator of 15. So we can just cancel this out. So cancel this will become 1, this will become 5. Cancel this, we just have 2, and this will become 1. So our answer will just be 2/5. Okay, our y here, y coordinate will be just 2/5. So in here, as now we can solve, we already solved our x coordinate and our y coordinate. So this one, our centroid here is just value of x coordinate of 3/8 x coordinate, and our y coordinate will be y, it's just 2/5. So if you have a plate here, and you can turn the curves to find the centroid, that's what your value is of x coordinate and y coordinate. So anyways, that's for our centroid.